This is Module 1 of Math 5840, Video 1. In this video, we're going to introduce the concept of a network. We're going to see a couple of examples of a network, and we're going to give the formal definition of a network. So, a network is a set of elements and a relationship defined on the set of elements. So to give an example, we need to think of a set of elements, and then we will define a relation on the set. So for our example, let the set of elements be people. In particular, let's let the set be the set of all U.S. senators in the year 2004. Now that we have our set, we need to define a relationship on the set. So we're going to say that two senators are related if they have ever voted yes on the same bill. So if they have not ever voted yes or for the same bill, they're not related. Otherwise, they are. Given the set and a well-defined relation on the set, we can represent this with what we commonly think of as our network. Each element of the set is represented in this case by one of the colored ovals, and the relationship is represented by the connecting lines. So if two senators have voted yes on the same bill, then there is a connecting green line. The color coding is also giving us information. The senators that are Democrats are colored blue, and the senators that are Republican are colored pink. I think it's supposed to be red, but it looks pink. There's also more information given by the thickness or the boldness of the lines. The more the senators have voted yes on the same bill, the thicker or the heavier the connecting line is. So just at a glance, we can see what this relationship does to the set of senators. We see it actually groups them by party, so we can tell that the voting goes along party lines. We can see a couple of exceptions, that is, which senators have crossed party lines to vote yes on the same bill, and which senators haven't voted at all. The senators that haven't voted at all have no connecting lines. As the previous slide illustrates, when we have a picture representation of our set with a relation defined on it, which is what we usually think of as a network, then we obtain a powerful visualization tool. Now, the connecting lines of a network can have properties associated with them. For example, they might have direction assigned to them, or they might have assigned weights. We'll see this in our next example. In this example, this direction applied to the edges would indicate, for example, that 1 is related to 3. The vertex or the circle labeled 1 is related to the circle labeled 3, or element 1 is related to element 3. But notice that doesn't mean that 3 is related to 1. So in this case, the relationship is not symmetric. Our definition of a simple network is the pair V, E, where V is the finite set and E is the relation defined on the set. Since this is a simple network, the relation is symmetric and anti-reflexive. But if it's a directed network, then the relation is not symmetric. This is what we've seen in our examples. Now, network science is a fairly new interdisciplinary science. It overlaps quite a bit with graph theory. What we are calling networks are called graphs in graph theory. However, the questions that are asked in network science pertain to large and complex structures as opposed to a general structure in graph theory. There is a lot of terminology that refers sometimes to the same thing, depending on whether you're looking at the network in terms of network science or in terms of graph theory. So, a network is a graph, or a graph is a network, depending upon your discipline. We're going to call what we have seen and what we have defined as a pair, a set with a relation defined on it. We're going to call it a network. The elements of the set that are represented are called either vertices or nodes, and we will refer to them as nodes. The connecting lines are called links in network science and edges in graph theory. So to be consistent with network science in the textbook that we have chosen, we're going to use networks, and we're going to refer to nodes as representing the elements of the set, and the connecting lines are links. So we have defined what we mean by a network and seen a few examples. We've clarified the terminology, so if you're familiar with networks from exposure to graph theory, we're going to use the term nodes for the vertices and links for the edges. And this is the material that's covered in sections 1.1 through 1.3 of our book.